Hello. So we're going to be going through the next section of Unit 5, which is arithmetic sequences. An arithmetic sequence is a sequence where the difference and that's subtraction, remember, between terms is always the same. The difference between these terms of an arithmetic sequence is called the common difference. And it's symbolized with a lowercase d. So it's a common difference because every single time you subtract the first and second terms, you get a number. You subtract the second and third, you get the same number. You subtract the third and fourth, you get the same number. It's a common difference. So we wanted to determine if each sequence here is arithmetic. And if it is, we want to give the common difference and we want to give the next two terms. So to do that, we're going to have to find a couple of the terms first. So we're going to go 1, 2, 3, 4. That should be plenty. So term 1, that's going to be 3 times 1 plus 5. That's 3 plus 5, which is 8. Term 2 is going to be 3 times 2 plus 5. That's 6 plus 5, which is 11. Then we're going to have 3 times 3 plus 5, which is 9 plus 5, which is 14. And then we're going to have 3 times 4 plus 5, which is 12 plus 5, which is 17. So looking at these, going from 8 to 11, 11 to 14, and 14 to 17, that's pretty easy to see. Okay, so 11 minus 8 gives us 3. 14 minus 11 gives us 3. 17 minus 14 gives us 3. So is this arithmetic? Yes, it is. And the common difference, lowercase d, is going to be 3. There's a formula for an arithmetic sequence where the first term is a sub 1 and the common difference is d. The nth term is defined by this formula. So it's a sub n equals, we're going to have the first term, so a1, plus the common difference times whatever term we're looking for minus 1. So this is the first term. This is the common difference. And n minus 1 is the term number, take away 1. So we want to find the 13th term of this arithmetic sequence. So we're just going to plug things in. Well, what is our first term? a1, in this case, right here, the first term is 2. We need to find what our common difference is. So d, well, 6 minus 2 is 4. 10 minus 6 is 4. 14 minus 10 is 4. So our common difference in this case is going to be 4. So the formula we'll end up with is a sub n equals 2 plus 4 times n minus 1. And in this case, they're asking us for the 13th term, so we're going to plug a 13 in for our n's here. So we'll end up with a sub 13 is 2 plus 4 times 13 minus 1. So that's 2 plus 48, which gives us 50. And now you could work this out a little bit further because we have term 1, 2, 3, 4, 5. So 6, 7, 8, 9, 10, 11, 12, 13. So if you extend this out a little bit further, you would have 18, and then 22, and then you would have 26, 30, 32, 36, 40, 40, oops, 30, made a mistake back here. So 30, and then 34, 40, making all kinds of mistakes. 34, 38, if I'm adding 4 on each time, 42, 46, and then term 13 would be 50. So 22, 26, 30, 34, 38, 42, 46, 50. You're adding 4 on each time, and you still get to the 50 for term 13. Sorry about that. Can't add 4 in my head very well, apparently. So write an equation for the nth term of this sequence here. So we have negative 98, negative 89, negative 80, negative 71. So we want to figure out what our common difference is. How much is each of those going up by? Well, from 98 to 89 is going to be 9. You're adding 9 on. 89, negative 89 to negative 80 is you're adding 9. Negative 80 to 71 is you're adding 9. So our common difference is going to be 9. The first term, what we start with, a sub 1, is going to be negative 98. So if we write an equation for this, it's going to be a sub n equals negative 98 plus 9 times n minus 1. And in this case, they're asking us for the 15th term. So we're going to go ahead and plug in. A sub 15 is negative 98 plus 9 times 15 minus 1. 15 minus 1 is 14, times 9 gives us 126. So this is going to be negative 98 plus 126. And our final answer there will be a positive 28. So the 15th term is positive 28. Last one on this page here. We have the 8th term of a sequence. So we have 1, 2, 3, 4, 5, 6, 7, the 8th term. And we know that that is going to be 75. We go out a whole bunch more spaces, and we know that the 20th term, somewhere out here, is going to be 39. So we need to figure out 3 things. They're asking us what is the first term, what is the common difference, and what is the formula for this. So there's 3 things we're looking for. Well, we know that this is an arithmetic sequence. They say it's arithmetic. So what we have to do is figure out what is this going up by each time here. What is it going up by every time so that we can get to 20? Well, it's the same amount. So we can do, to start out, we can do 75 minus 39. 75 minus 39 gives us 36. Then on the bottom we can do 8 minus 20. Well, 8 minus 20 is negative 12. So 36 divided by negative 12 gives us a negative 3. So our common difference is going to be negative 3. Because if you start at 75 and subtract 3 each time, you will eventually get down to 39, which will be the 20th term over here. To find our first term, we have to plug back into the formula. And they actually told us right up at the beginning that the 8th term is 75. So if we use the formula a sub n equals a sub 1 plus d times n minus 1, we can plug stuff in there. So we know that our 8th term is 75. So 75 equals a sub 1 plus our common difference is negative 3 times, we're looking at the 8th term, so 8 minus 1. So 75 equals a sub 1 plus negative 3 times 7. So 75 equals a sub 1 minus 21. If we finish solving that, we will end up with our first term equals 96. From there, it's just a matter of plugging into the formula. So we're going to have a sub n equals our first term, 96, you can actually just do minus 3 times n minus 1. And that is your whole formula. I know that's a little tricky. We will work on it a little more as we go. So, arithmetic means are any term of an arithmetic sequence. So if we want to find 3 arithmetic means between 4 and 28, this is actually super easy. So we have our first term, and we want to find 3 terms in the middle. Oops. So our first term is 4. We want to find 3 terms in the middle, and our last term is 28. So if you notice, we're going from 4, we're going 1, 2, 3, 4 spots. So 28 minus 4 is 24. And we're going 1, 2, 3, 4 spots. So 24 divided into 4 pieces gives us 6 each time. So 4 plus 6 is going to be 10 if we add 6. Add another 6 and we're at 16. Add another 6 and we're at 22. Add another 6 and we're at 28. So our 3 numbers there would be 10, 16, and 22. You can also do sums of these. So these are called arithmetic series. And they can be found using the formula S sub n equals n times a sub 1 plus a sub n over 2. So that's saying you're multiplying the term number times the sum of the first and last terms and dividing it by 2. So to find the sum of the first 20 terms of this right here, 9.5n plus 2.6, what you're going to do is you're going to say, well, we want s sub 20. So to do that, we're going to have 20 times our first term. Well, we got to find that. So a sub 1 equals 9.5 times 1 plus 2.6, which is actually going to give us 12.1. So we'll plug 12.1 in here. And then we need to find the 20th term. So a sub 20 is going to be 9.5 times 20 plus 2.6. And that actually gives us 192.6. So plus 192.6, all divided by 2. So this actually ends up to be S sub 20 is going to be, if we multiply and add that out, it's going to be 4,094 divided by 2, which is 2,047. So there were 3 steps of that. We had to find the first term, then we had to find the 20th term, and then we had to plug it all back in to get our final answer, which is 2,047. That last one down there is a little trickier. We might go over it in class tomorrow. I haven't quite decided yet, so someone asked me, and we'll probably go over it tomorrow. Other than that, have a wonderful day.